Hello and welcome everyone. I am absolutely thrilled to have you here for another explainer. Look, if you're a focused learner trying to wrap your head around how modern applications are really pieced together, well, you're in exactly the right place. Today, we're doing a complete tech teardown of a seriously fascinating project called CodeGuard AI. We're going to pop the hood on this system, look at the gears turning inside, and figure out exactly how it blends web development, machine learning, and artificial intelligence into one cohesive package. So, grab your virtual hard hats, because we're getting right into the architecture.
Okay, let's take a quick look at our structural blueprint for today. First up, Section 1 will meet CodeGuard AI. Then Section 2 will see how the scanner works. Section 3 covers the three-layer tech stack. Section 4 explores real-world industry parallels. And finally, Section 5 will talk about who this project is actually for.
All right, let's kick things off with Section 1, Meet CodeGuard AI. We'll start at the surface level before we dig into the back-end logic.
So, what exactly is this thing? Well, CodeGuard AI is a Django-based code vulnerability scanner that utilizes machine learning to assign severity scores and AI to suggest plain English fixes. The absolutely crucial point here is that this tool doesn't just find flaws in your code, it actively ranks them and literally tells you how to fix them. At its core, yes, it's designed as a final-year college project, but honestly, it operates with the logic of a much more mature system. Instead of just throwing a giant wall of red error text at you, it uses that machine learning model to give a specific severity score to every single finding and then hands that data off to an AI API to generate explanations that a human can actually understand.
And that brings us to the core promise of the tool. Paste your code, get a security report in seconds. This perfectly captures what they're going for, getting a comprehensive security breakdown without all the manual headaches. You just paste a chunk of code into a box and boom, the system hands back a structured list of everything sketchy it found, categorized all the way from low to critical. Plus, it explains exactly why each finding is a problem and what you need to do to fix it.
Moving right along to Section 2, how the scanner works. Let's trace the actual journey of a piece of code through the system.
The workflow is incredibly streamlined. Step 1, you either paste your code directly into the browser or upload a file. The system takes Python, JavaScript, or PHP files up to 500 kilobytes. Oh, and if you don't have code handy, the UI actually has these great try a sample buttons that load pre-written vulnerable snippets. Honestly, this is a lifesaver for a live demo if your network connection randomly drops. Anyway, Step 2, the system scans for vulnerabilities. The results then populate on this really slick, dark, terminal-style dashboard, showing your security score, a severity breakdown, and these expandable cards with syntax-highlighted code for each finding. And finally, Step 3. With just a single click, you can generate a beautifully ranked PDF report of all those findings.
Now here is a massive safety mechanism you need to know about. The code is never executed. There's no eval, no exec, no shelling out to an interpreter. The findings come purely from syntax tree inspection and pattern matching. You know, examiners absolutely love hearing this because it demonstrates a real, fundamental understanding of secure system design. You're relying entirely on safe inspection methods instead of running super risky execution commands.
All right, let's peel back the UI. Section 3, the three-layer tech stack. This is the really fun part under the hood. For a college project, this stack is an absolute powerhouse. It seamlessly blends standard Django architecture with ML and advanced LLM APIs. Check this out. You've got Django 5.x handling the web framework and routing. Then, scikit-learn using a RandomForest model for the machine learning classification. The AI brain? That's powered by the Groq LLaMA API, specifically the LLaMA 3.370b versatile model. To actually parse and tear down the code, it uses Python's built-in AST module. It relies on wheezyprint to generate those professional PDF exports, and tying the whole shebang together is a trusty, standard SQLite database.
But notice the clever engineering compromise here when it comes to parsing. Item 1 for Python code, CodeGuard AI uses Python's standard library AST module to walk an actual structural syntax tree. This is great because it catches deep structural issues that simple keyword searches totally miss, with no external grammar to configure. But then look at Item 2. For JavaScript and PHP, the system uses a lighter regular expression rule engine to evaluate string matches. Why the difference? Well, writing a full JS parser from scratch for a college project is just not a great use of your final semester. It's a highly practical, real-world compromise to keep the project scope manageable.
And how about this number? 90%. By using a RandomForest classifier trained on a synthetic, labeled dataset, the system figures out exactly how bad a vulnerability is, ranking it low, medium, high, or critical. The training script actually prints out a classification report and feature importances. Hitting a highly defensible 90% test accuracy is huge. It proves to whoever is grading this that the machine learning component isn't just window dressing, it's doing actual measurable classification work. A fantastic talking point for Aviva for sure.
To round out those 3 layers, we have the AI API integration. Groq LLaMA takes over once the code is parsed and scored, turning those raw technical findings into human-readable explanations and plain English fixes. And the architecture here is actually super smart. The responses are batched and cached right in the SQLite database. What that means is, if you create an optional user account and reopen an old scan from your history, it costs exactly 0 additional API calls. It's incredibly efficient.
Okay, let's zoom out a bit. Section 4. Real-world industry parallels. Because this isn't just an academic toy.
CodeGuard AI basically perfectly mimics enterprise-grade CI/CD pipeline scanners. Think about it. The automated code scanning feature? That's exactly what tools like Bandit or SemGrep do in pre-commit hooks. The ranked severity scoring model, SonarQube, which you'd use to block critical merges in a startup repo if a junior dev tries to push insecure code, and that security risk dashboard reflects the kind of enterprise audit tools agencies use when they inherit a messy client codebase and need a lightning-fast risk read before quoting a maintenance contract. This project directly models the very first line of defense in modern software development.
So, Section 5, who is this project actually for? Let's take a look.
If you are staring down a tight deadline, this project is an absolute lifeline. It's perfect for final semester BCA or MCA students hunting for a unique cybersecurity topic. It's also fantastic for BTech computer science students because, like we just saw, it gives you a robust, defensible machine learning component that you can easily explain in under 2 minutes. But honestly, the biggest win is that it helps you stand out in a massive sea of basic CRUD applications. It saves you from being the 15th person this month to submit a standard library management system.
I do have to give you one honest warning about this stack, though. Watch out for the PDF generation on Windows, because it requires installing the GTK3 runtime via a winget command. Getting WheezyPrint to export PDFs on Windows means dealing with system-level dependencies. Basically, a simple pip install won't cut it. You have to run that winget command. It literally only takes about 5 minutes, but if you've never messed with system-level dependencies before, it might feel a little intimidating. It's a great learning experience, but definitely something to keep in mind before you dive in.
As we wrap up this explainer today, I want to leave you with one big question to think about. Is your code actually secure, or is it just lucky? CodeGuard AI shows us exactly how we can move from just hoping our code is safe to systematically proving it, ranking the real risks, and automating the solutions. I really hope this teardown inspires you to explore the world of automated vulnerability scanning in your own projects. Thank you so much for hanging out with me today, and keep learning.